Chapter 1, Matter, Measurement, and Problem Solving. So, a question, what do you think? What do you think is the most important idea in all of human knowledge? That's a tough question. There could be lots and lots of answers to that. Well, if we just think about scientific answers, and since we're in chemistry class, you might expect that we would do that. It might be this: the properties of matter are determined by the properties of molecules and atoms. So the properties of the bench top that you're leaning your elbows on, it's glossy and hard and black, and it's a solid. Those properties are because of the properties of the individual atoms and molecules that make it up. If those particles, those atoms and molecules were different, the desktop would be different. It might be a liquid. It might be bright green. So when we understand matter at this particular level, it gives us a great deal of control over the properties of matter. And that's what has enabled many of the advances in technology and in material science and all sorts of things like that. Well, what are atoms and molecules? Atoms are the tiny particles that compose matter. They are the fundamental building blocks of matter. I like to use a lot of analogies because chemistry is full of some things that are very abstract, some concepts that are very abstract. We talk about a lot of things that cannot be seen. I'm a visual person, and I need to at least have pictures in my head of what's going on. So I think of atoms as being a lot like individual Lego bricks. You guys know what Legos are? I think most people do. So you have these little plastic bricks, right? And you can combine them in all sorts of ways. You could make a dinosaur or a tree or a spaceship based on how you put the Legos together. Okay? So atoms are like that. It's actually rare in nature to find free atoms. There are some elements that do that, but most elements do not run around as free atoms. They combine with other atoms and form molecules. So here's an example of a molecule. This is a water molecule. It's composed of one oxygen atom and two hydrogen atoms. So you might think of it as one red brick and two of the little white bricks. Every water molecule has that same configuration of atoms. So a molecule is like the individual atoms stuck together. Okay, you've clicked them together. The properties of the water molecule determine the properties of water. So we're familiar with the properties of water, right? It's a liquid at room temperature. You can drink it. It's good for you, but you can also drown in it. Too much of it's bad for you, right? Does it burn? No. We actually use it to put out fires, right? Just feel free to take a place. So here again is an illustration of a water molecule. And this is a hydrogen peroxide molecule. The difference between these is seemingly very small, right? This one has two oxygen atoms with the two hydrogens. This one has one. And sometimes students get upset because, we're so detail-oriented, right? Oh, I was close. I was only off by a factor of 10, or I just transposed those two numbers. Can't you give me full credit? There are situations where details matter a lot. Think about an email address. You're going to be late for work, and it's a really important thing happening, and if you don't let your boss know, he's going to fire you. So you send him an email, and you get one letter wrong in the address. Does he get your email? No. Sometimes details matter. This detail matters. You stick another oxygen in there, you have hydrogen peroxide, which is very different from water. Pure hydrogen peroxide is very unstable, and it's very toxic. Now, you may be familiar with hydrogen peroxide solution that you buy at the drugstore. That's about a 3%, I think, solution. Could be 30. And that can be used to clean wounds. You pour it on a wound, and it fizzes and bubbles, and it kills the bacteria. You use stronger stuff, and it's going to destroy your skin and can kill you. Hydrogen peroxide is also used to bleach hair. Does water bleach your hair? No, we use water to wash our hair, right? But hydrogen peroxide will take the color out of your hair. Okay, so seemingly small difference in the structure of the molecule, huge difference in the properties. Okay? So, if we want to understand the substances around us, then we need to look at the atoms and molecules that compose them. And that is the central goal of chemistry. So one way to define chemistry is, it is the science that seeks to understand the behavior of matter by studying the behavior of atoms and molecules. Here's another illustration. This is graphite. That's the lead in your pencil. Pencils actually do not contain any lead. That is just called that, but it's actually graphite. That's carbon. And in the form of graphite, carbon atoms arrange themselves in this way. They form basically two-dimensional molecules, and because they're two-dimensional, they are very slippery, and that's what makes graphite a good lubricant or a good writing material, because it'll slide off and leave a mark behind it. This is a picture of a diamond. A diamond is also pure carbon. But here the carbon atoms are bonded to each other three-dimensionally. And this gives diamonds the beautiful clarity and shine that they have. It also makes them extremely hard. Graphite is very soft. Carbon is very hard. So these two substances are composed of the same kinds of atoms, but how those atoms are connected to each other is different, and so the properties are very, very different. Any questions?